converse of the Pythagorean theorem. So the converse means the opposite. We're going to go backwards from this. So our main idea here, the converse of the Pythagorean theorem, if the equation a squared plus b squared equals c squared, you'll remember that's our Pythagorean theorem, is true for the side lengths of a triangle, then the triangle is a right triangle. So before we said, well, it's a right triangle, so I can use the Pythagorean theorem. Now what we're saying is, if I can use the Pythagorean theorem, then it must be a right triangle. We're working backwards from something that we figured out to something that we thought we knew before. So again, remember that our right triangle is a triangle where we have a right angle in one of the corners. A and B are the shortest sides, and the hypotenuse, my C, is my longest side. That's an important part here when we're working with this converse of the Pythagorean theorem. Remembering that A and B are the shortest of the three sides. So let's tell whether the triangle with the given sides is a right angle. So they've given me 28 inches, 21 inches, and 20 inches. Don't forget that the legs are always the shortest side. So as I fill in this equation, I want to take the two smallest numbers and put them in for my A and my B. So I've taken 20 and 21 and used them for A and B, the legs. I come up with 400. When I square them, I get 400 plus 441, and my 28 squared is 784. When I add them, I get 841. That's not equal to 784, so this is not a right triangle, since the square of the two legs is not equal to the square of the hypotenuse. One more. 1 and 2500 millimeters, 1 millimeter, and 7500 millimeters. Let's see if this is a right triangle. Again, I want to take the two smallest sides and put them in for my legs. The largest side should be over here as my hypotenuse. So I'm going to put my 1 squared plus 7500 squared equals 1 and 2500 squared. I'm going to grab those squares. When I add them together, I see that the sums are equal to each other. So yes, this is a right triangle. So using the Pythagorean theorem, instead of trying to find a missing leg because we know it's a right triangle, we are using the lengths of the sides that we already know to decide if this actually is a right triangle.